So again, we're going to talk about perpendicular lines. Okay, everybody ready? So lines, segments, or rays that intersect to form or intersect at right angles. How many degrees are right angles? 90. Are what we call perpendicular. Perpendicular. Okay, it says it right up there. Perpendicular. And then just up somewhere on the top of that, you want to write this down. That symbol, that upside down T, means perpendicular. So a lot of the times I will use that instead of writing the word because it's quicker. Okay, so that upside down T means that lines are perpendicular, which means they intersect at right angles. Segments or rays can be perpendicular to lines or other segments or rays. And then it says the right angle symbol represents that the lines are perpendicular. So if I have two lines that intersect, what I'm going to do so that you know that they are perpendicular is I'm just going to put a little box in one corner. Does that mean that's the only corner? That's the only right angle? No, all four of these are right angles, but I will put one box there. That lets us know that those lines are perpendicular. Or I could write it like this, and I could say line AB is perpendicular to line CD. Okay, so that's what it would look like in symbols. So when you see that, don't ask me what that means. We're just talking about it. It means they are perpendicular, which means they form right angles. All right, and then perpendicular lines intersect to form how many right angles? 4, yes. And then perpendicular lines intersect to form congruent adjacent angles. Congruent adjacent angles. Well, what are they all going to equal? How many degrees? 90. So does it make sense that those are congruent because they're both 90? Those are congruent because they're both 90. Those are congruent, and so are those. Adjacent is two that they share sides. So like this angle right here, and then this angle because they share that one side. They're next to each other, touching. That's adjacent. Is everybody good? Anybody have any questions so far? Alrighty. That picture is hard for me to read, so I'm going to draw it up here. Give me just a second. There's a lot going on in that picture. Okay, so that's what the picture looks like without all that stuff behind it, right? Can you see that in your picture? So first of all, I'm looking at what it tells me. It says we're going to find the values of x and y so that PR and QS are perpendicular. Okay, here's PR. Here's QS. We want them to be perpendicular, which means they're going to form right angles. Let me do that in a different color. Okay, so I'm going to start with y because it's the easier of the two. Does anybody have any idea what kind of equation I can set up to solve for y? It says that PQS is 4y minus 2, but what else do we know it's equal to? 90. So what equation would I write? Yeah. 4y minus 2 equals 90. And because they told me those lines were perpendicular, I'm going to start with y because it's the And so that one angle, PQS, is equal to 4y minus 2, which is also equal to 90. So I would like you to take a minute and solve that equation for y. If you need a calculator, grab a calculator. We should all be solving this equation on our paper if we have not already. I've got it written on the board. 4y minus 2 equals 90, based off of knowing that those lines are perpendicular. What's the first step in solving this for y? Add my 2 over, yep. So that's going to give me 4y equals 92, and then what? Y by 4. And so y is going to equal, what is that? Okay, so there's y. What else did it ask me to solve for? X. Okay. Now, I have two angles who have an x in them. I have this angle right here, SQT, which they say is 5x plus 6. And then I have TQR, which is 2x. I know that QS is perpendicular to PR. So if that's 90 degrees, what is this whole one over here? That's also 90, right? Does that mean 2x equals 90? No. Does that mean 5x plus 6 equals 90? But it means that together, what do they equal? 90. So how would I write an equation to figure that out? I'm going to take the top angle, 5x plus 6. And then I'm going to add the little angle, 2x. And I'm going to equal that to 90. Okay, the two angles together, when we put things together in math, we add them.
So if they were like one on this side, or this side would make it equal.
So like if they didn't have this here, and it was just this big angle and this angle, yeah, you could set them equal to each other. Which we'll get to some of those later. Okay, so solve that equation. I've got 5x plus 6. So this little angle here plus 2x, that angle here, is going to equal the whole angle, which is 90 degrees. Okay, just like before when we could take two segments and add them together to get a bigger one, we can do the same thing with angles. We can take two angles, we can add them together to equal a bigger one. Remember what we talked about yesterday with our equations? If they are on the same side of the equal sign, we just combine them together. We don't do opposites. What can I add together over here? 5x and 2x. That's going to give me 7x. Then I have that plus 6 equals 90. And then what? Subtract that 6 over. So 7x is going to equal 84. And then we're going to divide through by 7. And so x is going to equal 12. Okay. So for that question, I found both x and y using those equations. X was 12 and y was 23. Anybody have any questions so far? So it's talking about interpreting diagrams, basically being able to look at pictures and identify what's going on. And it says points of intersection can be assumed because you can clearly see where two lines intersect, correct? Like if I'm looking at that picture, where do my two lines intersect? At point B. So you can assume that because you can see that. But remember, we've talked before that you can't assume other things. Like if something looks like a right angle, I can't assume it's a right angle unless I tell you that. If two lines look like they're perpendicular, you can't assume it unless I tell you they are perpendicular. And you can also identify vertical angles and you can identify linear pairs in any picture. So if I'm looking at the picture of what it's describing, it says angle ABD. I'm going to highlight that, and there's nothing you need to do right now. We're just talking. So angle ABD, maybe, is this angle right here. And angle CBE, this one down here, those are vertical angles, right? This angle and that angle. And what did we say vertical angles are? They're always equal, congruent to each other, yeah. And then it says that angle EBA, so let me erase and show where that is. EBA is this angle. And angle ABD, this angle, are a linear pair. And what do we know angles that are linear pairs add up to be? 180. So the measure of those two angles, because they are a linear pair, add up to be 180. Everybody ready? So what I want you to do is basically look at this picture and answer either yes or no. Yes, I can assume those are true, or no, I cannot assume those are true based off of what I see in the picture. Okay, just a yes or no answer. Yes, you can assume it based off of the picture and what it represents, or no, you cannot. Okay, answering questions A through H. Yes or no? Yes, I can assume it. No, I cannot. Again, above that, it tells you what we can assume. We can assume points of intersection. We can assume linear pairs because we can see it in the picture. We can assume vertical angles because, again, we can see those in the pictures. What we can't assume is a right angle unless I have a marking. We can't assume perpendicular lines unless I have a marking. We can't assume congruent angles unless I have a marking or unless they're vertical. So we're just answering A through H, yes or no. Everybody needs to be working on those right now. Yes, I can assume it based on the picture. No, I cannot. adjacent.
Yes.
Isn't it? Yes, they are adjacent.
Oh, I thought.
I'm going to kind of highlight these, each one, as we talk about them so that we can see it a little bit better. So I'm going to start with ray CE. Remember, a ray starts at the end point, whoops, and goes through the other end. So that's ray CE. And ray CF, are those opposite rays? Can I assume that based on the picture? Yes, because they have the same endpoint. They go in opposite directions and they make a line. So that is, yes, I can assume that based off of the picture. Is everybody okay with that? All right. Next one, BGC. So angle BGC, that angle here. And angle KGC are a linear pair. Do those two angles, are they next to each other and form a straight line? Yes, so we can assume that as well. All right, ABJ, so here's ABJ, and CBG. Are those vertical angles? Yes, they are. Remember, vertical angles are across from each other, formed by two intersecting lines, which those are. All right, BCG, there's BCG, and DCF, are those congruent? Can I say that they're congruent? No. They might be, but I don't have any information to say that they are, so can I assume that they are? No. You cannot ever assume congruence unless you're told some information, or unless they're vertical. All right, line segment BE, so that's, whoops, this piece right here is perpendicular to line IF. Can I assume perpendicularity? No. Do I have any markings to tell me that those are perpendicular? No. So I cannot assume that as well. If I had put a little box there, then the answer would be yes. But because there is no box, we have to say no on that one. All right, next. EBC is this angle here. And GBC is this angle here. Can I assume that they are complementary? Do we know anything about them? I don't know any measures. I don't know any perpendicular lines, so that one is also no. ICH is this line right here. HCD is this here. Are those adjacent angles? Yes, they share a side. They are next to each other. They do not have to be congruent. They do not have to make a line. They just have to be sharing a side and a vertex. And then lastly on this is that segment BC, so this piece here, is an angle bisector of angle ECG. Do we know anything about those angles? The yellow cuts the blue in half is what it's saying. Do I know any information to tell me that? Do I have any markings on any congruent angles anywhere in this picture? No. So can I assume that it's an angle bisector if I don't know that those angles are congruent? No. Okay, so you just got to be careful. You can't assume congruence unless they're vertical. You can't assume perpendicularity. You can't assume complementary if you don't know anything about your angles. Here, would I say that those two are complementary? Based off of what I have? Yeah, because they add up to equal.
Wait,
complementary. What does that mean?
I mean 90.
90, yeah. Everybody good? It's Friday and everybody's tired, it seems. All right, I want you to take a minute and answer those last 5 questions based off of that last picture. It's asking about some complementary angles. You do have some markings here, so pay attention to those. You're going to answer like angle numbers and then angle measures. Okay, what I want you to do is answer those 5 questions. I'm going to draw this picture up on the board so I have more space to write. But I want you to go ahead and work on those 5 questions. 90? All right, everybody needs to be working on answering those 5 questions. Two angles that make a straight line. Or angle 1 and angle 2. Straight line. I'm coming. Are you? I'm coming. Oh, I fell. We should be answering those last 5 questions. Hold on. Of course, my stuff is not wanting to work either. My tablet is not seeming to want to connect. So let's look at question 1. It says angle 1 and what other angles are complementary? What does complementary mean? They add to equal 90. So what angle in this picture together with angle 1 is giving me 90 degrees? 2. Okay, how do I know? Because I have that little marking there. Those two together equal 90. So that's going to be angle 2. Number 2, angle 5 and what other angle are supplementary? 6. They are a linear pair. They give me 180. Are 1 and 2 a linear pair? Do they give me a straight line together? No, a straight line is like this. Together they give me this L shape. That's not a straight line. So are they supplementary? No. How are the vertical and horizontal lines in the figure related? Vertical and horizontal lines, what would we say they are? They're perpendicular. And I'm just going to use my symbol. Okay. How do I know that? Because that one angle is a right angle, which means all of them are right, correct? All right, so number 5, we are given, what are we given? The measure of angle 2 is 27 degrees. And we are given that angle 3 is 59 degrees. And we're supposed to find the measure of each one of the other angles. Let's start with angle 1. Anybody have any idea on how to find the measure of angle 1? We're going to subtract angle 2 from 90 because these two together give me 90. So I'm going to say 90 minus 27. And that's going to give me 63. What about angle 4? How can I find that? Same thing, but am I using 27 again? I'm going to use 59 because these two angles together are 90 as well, right? So I'm going to say 90 minus 59. And that gives me 31 degrees. And now probably the easiest of all, what is angle 5 going to give me? 90 degrees. Okay, so just one angle and another perpendicular. And what about angle 6? 90.